Okay, 1, 1, 2. Okay, I think you can hear us now.
Hi guys, thanks for having us.
In front, you mean? Okay, so thanks for having us. So my name is Marcin, and I'm COO of Redstone and also co-founder of EVM Warsaw, which is a conference and a hackathon in Warsaw, Poland.
And I'm Jacob, the founder of Redstone, but also with a technical background. So I'll be dealing with the boring stuff, and I let Marcin to introduce you the topic.
Yeah, so you always have to have someone that deals about the boring stuff to create value, right? And then the other guy that is capable of presenting a little bit, maybe. So today we're going to talk about stateless oracles. As we got introduced, like oracles is this weird concept that many people think they understand, but maybe on the surface level. And there are many caveats when you dig into that we will try to break it down. So maybe to start, so that we are no strangers, we as Redstone last year raised $7 million as our seed round from notable Web3 investors. It's just to show you that not only us, the builders, but also investors see value in opening up the Oracle market and innovation over there. Our product has been used on many hackathons last year. Altogether, I think 5 prizes across 5 different hackathons were distributed using our technology. One of them was Lens Score. So using our Oracle, we aggregate data from Lens protocol about the score of a given handler, and then we can provide it to your smart contract so that you can create, for example, anti-bot or like a system for rewards or anything similar to that, which shows that finally, Oracle delivers not only pricing data, but it can be any arbitrary number, right? We talk with developers. Like, it's not like we close ourselves in a garage for half a year on a year, and then we come with the product at the end. Last year, we participated 12 international events. One of them was EVM Warsaw. Like, Stan is also one of our supporters, old friend with Jakub. From old days like in 2018 and 19. And altogether right now we have 20 dedicated people. Apparently right now all of us are from Poland because over there we have good engineering ratio and also like pretty great talent. So maybe let's start with a very simple question, what's an oracle? So oracles, for those that know, deliver various types of data on-chain for smart contracts and dApps. To visualize the flow, on one hand, you have various sources of data, you have an oracle, and then you have various ecosystems that the data is delivered to so that dApps and smart contracts can utilize that data for their protocols, right? And right now, the Oracle approach is fairly simple, I would say. So you just take the data, you put it on chain with a heartbeat, so an interval, or a specific deviation, and you update it regardless if anyone needs that or not. So it's just like outside of usage, it's just updated depending on the specific variables that you put over there. So we compared it right now to modems in the 80s that apparently were quicker than nowadays oracles as it is on the market. So we, and mainly like Jacob in the very beginning, had the idea, okay, we need to disrupt that space and create something that you can truly build the new financial system on top of, right? Because on that, you cannot. Like a quick example, ask any of your TradFi guy to come over to DeFi and tell them that the price feed is updated every 15 minutes. He's going to look at you and say like, huh? Really? Right. So what are the problems? Why we have such a market? So because pushing data on chain is expensive, it's non-scalable. So if you introduce new data feeds or you update it more frequently, your costs grow exponentially. So you can offer unlimited feeds, and the data is updated in very large intervals. And in 2020, 21, 22, 23, and as we go farther down the road, we see that the multi-chain or multi-layer 2 world is going to be the one that will be existing in. So it's not enough that you push data only to mainnet Ethereum. You have to push the same data to many ecosystems, which creates huge cost, right? Like the more ecosystems you have, the higher cost it gives you in the end. So DeFi potential right now is limited by oracles, especially on, for example, recently launched zk Sync Era, that we are already present, but many other incumbents cannot be that quick to launch at. Arbitrum, Polygon, or also like speed-optimized layer ones like Avalanche or Phantom. So now I will give you some food for thoughts. So you just not listen to me, but you can also put your brain into work. Ask yourself, who requires data? Layer ones and layer twos or dApps? The second question, can we deliver data to dApps omitting on-chain storage? So these are two different questions, but very important ones. And the third, last, if not, can on-chain delivery happen on demand instead of a heartbeat? Right? Because we already see the heartbeat or deviation. Can there be some other rules upon which we update the data? So answer to the first questions, dApps require data for their smart contracts logic. Like, if you push data to Ethereum, Ethereum is not going to send you like a thank you for data. I mean, it's useless for Ethereum as a chain. It's rather the dApps that are built on top that needs that. We can deliver data directly to dApps, omitting on-chain storage. Because, as I said, like on-chain storage doesn't require it, the dApps require it, so we can, instead of pushing on-chain, push it to dApps, and then their job would be to deliver it on-chain. Last but not least, if the architecture of the dApp doesn't allow us to put it to the dApp directly, because sometimes that's the case with the architecture, we can at least optimize the flow. If a dApp requires on-chain storage, we can still optimize the conditions upon which are the data updated on-chain. So for example, we can adjust the heartbeat to them or make it more like on-demand level as a dApp for a specific dApp. And now I'll pass it to Jacob on the more technical part. So the easy part is over.
OK, so networks like Ethereum and all of the equivalents following the EVM specification were never designed to store a large amount of data. Actually, like putting the information on-chain is penalized and disincentivized, as you need to do a lot of hops in the Merkle trees, fetching the data, a lot of input-output operation, etc. So it's very costly. And therefore, as we express the price in gas, let's imagine that you want to put like 1 gigabits of data on-chain. On Ethereum, we are going to pay about $80 million. Why? There are alternatives. So when we started working on that solution, we looked for a chain that is decentralized enough, but was designed and built with the purpose of a storage layer. And we discovered Arweave, started working on that. So for the persistent storage of data feeds, we utilize Arweave and then get lots of saving compared to putting data directly on chains that are going to consume the information. And still, when the data is being put on the Arweave network, somehow we need to access that in our contracts that are run on the Ethereum network. But we still can avoid getting through storage and can basically use only a call data structure. So the data is ephemeral and only available within a context of a single transaction. And the call data, as you may look, compared to other storage solution, is the cheapest alternative. So if we keep the data only in the call data during a transaction, then compared to getting that from storage and first putting that into storage, we can have a huge savings. So the traditional Oracle models work like there are multiple data providers that are pushing data to various chains. And you may notice some redundancy. So the arrows on the left side of this picture usually are the expensive operation, because you need to take data, put it into storage. And all of the data providers will need to do the same job again and again, pushing the data to different chains. And if you imagine like having 20 EVM-compatible chains, then you need to pay the gas price of each of them. And then the dApps can go to that chain, fetch the information, and make the user happy for having the available data on chain. What we changed in the design was the introduction of an intermediary layer. We call it like a data delivery network, which is combined of the streamer, which is a decentralized PubSub network. It's great for keeping the data for a short period of time and broadcasting it through the network. We also, as I mentioned, utilize Array for the persistent storage. Actually, it's a very nice combination because one gives you a very fast distribution, another one gives you like a full persistence, and we also use our own gateways just to make the interaction easier for dApps. So in our case, all of the data providers are pushing the data to the data delivery network. It stays there, and only when a user wants to interact with an application or a protocol, then the data is injected automatically to a user transaction and consumed on-chain. So and the same information, physically the same data packages, could be consumed on various chains because the data is only injected to a transaction when it's needed. The data delivery network remains the same across all of the various chains. So there are a lot of savings, as the storage in the data delivery network is very cheap, and obviously there are a lot of nice benefits, as the same application can basically use the same architecture if it's deploying on multiple networks.
Yeah, so as you can see on the first target layer 1s and layer 2s, these are like all EVMs, layer 1s and layer 2s, but we also started going beyond. So the first non-EVM connector that we created is for Starknet. Right now we are finishing one for Fuel. We also have one for Stacks, and there are other on the way under the development. So on EVM, it works out of the box. If we go outside of EVM, it's still possible, but it requires a bit of research and custom development from us.
Yeah, but generally the system is very modular. So even if we are targeting a non-EVM chain, it doesn't mean that we need to deploy the infrastructure from scratch. We just need to prepare a new adapter, something we call a connector, on a dedicated network, and it can consume the same sets of data. But there isn't a solution that fits it all, and definitely when we are talking about DeFi protocols, there are a lot of innovation happening there. So I've been describing to you the on-demand model when a user interacts with a chain and the data is automatically injected. But also recently we started working on something we call Model X, which was inspired by the cooperation with GMX, especially the work on the V2. And in that model we try to totally prevent any front-running possibilities. So in that situation, whenever a user interacts with an application, we record the intention to make a transaction, like open a position or increase a position in perpetual. And then that intention is being settled in the very next block with the price delivered by Oracle. But the price is not known both to the protocol and to the users, so it cannot be front-run. Because with a standard Oracle model, there's always a small delay between the data that's already on-chain and the moment when a user is interacting with a protocol. So the user can have access to the current state of the market, can discover the price before it's been put on-chain, then there's obviously an opportunity for arbitrage and exploit the protocol. But when the user needs to commit to a transaction before knowing the price, and the price is settled after that, then we eliminate all of the possibilities of arbitrage. And also when we started working on that solution and cooperating with various protocols, some of them are more traditional. So they got a code base that was well audited. They are used to work in a certain way, and they do not want to experiment with oracles and use a standard approach based on the interfaces implemented by incumbents like Chainlink. But still, you can benefit from having this decentralized distribution network using a classical approach by specifying what will be the rules of pushing data on-chain automatically. So we are not limited by the scenario when a syndicate decides how the data is being pushed on-chain. You can define your own rules, providing a relayer, and still fetch the data from the same source whenever it's required, by being 100% compatible with the old interfaces. So basically, how it looks from a point of the user, it's exactly the same as interacting with the standard dApp. apart from the fact that behind the scenes we are injecting an extra payload to a user transaction. It's all automated through our wrapper on ethers.js, and this extra information are the packages of same data. So despite we aggregate and keep the data off-chain from the point of view of a target chain when the protocol is deployed, still the verification happens on-chain. So we derive the security from the target network. When we are deploying that on Ethereum, all of the verification of signatures and timestamp happens on Ethereum. We also are integrated with multiple data sources. So for the, I think there are more than 50 sources, and for the most popular tokens, like for example Ethereum, we got like 40 sources. And we parse this data about all of the individual sources, and they are publicly available on Arweave. So if you are interested into the history of the price, for example, of Ethereum in the past, and we'd like to compare the data coming from various sources, then you can have access to that as well.
By the way, the price of Ethereum wasn't from today, like easy. I mean, I saw that some of you that might be shorting had a heart attack, but yeah.
No, it's from the next week. So we provide custom data feeds. It's not only the prices of tokens, but also some commodities, currencies, also derivatives like stake tokens, LSDs. We got to provide prices for LP tokens. And also for some hackathons, people are creating a really interesting use cases. We've been on one hackathon in Ukraine, so they decided to put all of the information about the war on chain. And the protocol is very customizable and open for anyone to put any data feeds they want. I'll let you summarize.
Yeah, so as you could see, like the bottom line is, in 2023, we need more customization depending on the dApp. We cannot think about in the same terms as we did in 2020 DeFi summer, that there is like one approach to oracles, and let's push it to any dApp that will use it in the same way. dApps want to be capable of defining what's the heartbeat or are the rules, what data they require, like what are the data feeds. And in our model, we also allow the dApps to see who from they consume the data, which means you don't just receive at the very end the final aggregation. You can track like who this specific price feed came from. So we take the data off-chain from enterprise-grade data providers, Kaiko, Flow Traders, CoinGecko, CoinMarketCap, and many more. And for example, if you as a user don't like a specific data provider, you can disregard this data provider. To give you a real-world example, imagine we are in August 2022. You already smell that something is bad with FTX, which apparently was a data provider for many oracles. And you could potentially, for example, disregard the data that they provided and omit a potential crash of theirs later, right? Or even if you are consuming, you have the information that you are consuming from FTX. And when you see the FTX crash, you know the anomaly is because you are consuming data from them, not because of the whole market is volatile and so on. So you have better like transparency across the whole usage. We also integrate data from over 50 biggest centralized exchanges, but it's not limited to that. We also take data from on-chain sources. So we can provide you a TWAP, LP tokens, specific tokens for the ecosystem that you can ask for, liquid stake tokens, you know, like right now it's very trendy topic, or NFT and other types of data. So a couple of benefits of that design to sum up. So it's scalable, so more networks, and it doesn't require from us to have like higher costs of keeping the system. We cover right now over 1,000 of assets and non-standard data, and nothing stops us from adding like new sources if you need so. We right now in a core model update price feed every 10 seconds, and with the Redstone X, so this no front running model, we can go even sub-seconds. So right now on Arbitrum, we are testing delivering price feed every block, which is like 0.4 seconds as far as I remember. And it's cross-chain by design. So there is no waste of gas when you require data. So the data is delivered where you need it, when you need it. You can check out the interface with the data that is available on app.redstone.finance. And our documentation is very much updated as well. It's docs.redstone.finance if you want to dig yourself and check out what's possible there. So maybe a bit about the market trend in DeFi. So as you know, last year the whole DeFi shrinked, whereas the specific DeFi protocols such as derivatives, perps, options grew when it comes to TVL and basically the interest from users. So this Redstone X model, here is a bit of more of a breakdown, is a perfect fit for them to leverage the frequent update and omit the front running, because when you have like a lot of trades, of course, front running seems like a lucrative option. So let's recap on an example. So first you have a user that, for example, his request on GMX would be to open a short position. This request is registered in block number N on Arbitrum and via GMX. The price is not known yet. Anyone who works as a resolver can basically pick that transaction, pick a price from our data delivery network, connect the two, so you have price P with block N on the transaction, give it back to GMX, and GMX makes the settlement in the very next block. So between 1 and this N and N+1, you have 0.4 seconds. So then there is truly like no time for any front running for other users. So when it comes to protocols that trusted us, we've got a bunch on various networks. So for example, Delta Prime in February was top 3 quickest growing protocol when it comes to TVL and DeFi Llama, because we provided them feeds that no other Oracle could, like GLP token, you know, like in February it was a very hot one, and other like staked AVAX and so on. ZKX is on Starknet, so it's our long-term partner, Mula on Celo, and so on. From the notable ones that we are right now finishing integration for, it's Mento Labs, so it's the biggest DeFi protocol on Celo, Poolshark on Fuel Network, so the one that is coming fairly soon, and we are also chatting with Olympus DAO to prepare like specific dedicated solutions for them. So here is like Oracle in practice, how the Delta Prime model works. I don't know, you want to go ahead?
Oh, I can jump in. Give you some rest. So it's a very interesting protocol, kind of a decentralized prime brokerage service that allows you to multiply the effects of your money. So you get an account, and you're putting there, let's say like 100 USDC, but actually you can trade, you can invest, or you can farm with, for example, $500. And so you can borrow much more than you can deposit. So that's the opposite of lending protocols like AVA. And on any action that the user executes in that protocol, we attach the information about the prices of the assets. So whatever the user is doing, the value of all the assets that's being held, all of the invested positions in, for example, LP tokens or stake tokens, need to exceed an initial margin. And that checks are automatically applied to any user action, but obviously what's going to happen, let's say I put $100, I invested into LP tokens, and now the cumulative value of that position is something like $420. So we are getting close to our limit by a margin, which was this $100 supplied upfront. So for the security and for the solvency of the protocol, we'll need to liquidate the user position. And in that case, also the bots that are monitoring the system, and that could be run by any of the external users, need to monitor the price, read the price from contracts using our oracles, and liquidate the position. So it's both the data is injected to user's transaction, but also in the same way injected to the liquidation bot's transaction. And as I mentioned, the protocol could be used for trading, staking, or liquidity mining.
Yeah, so at the very end, we also wanted to invite all of you for the partner event of Ethereum Zurich, which is like E4 conference and a hackathon, starting 30th of August and happening until the 3rd of September. So over here you have the university vibe, right? Over there we also organize it at Warsaw University of Technology. It's a 19th century building, which is fairly cool. So I would love to see all of the faces over here, also over there in Poland. Thanks a lot for listening. I hope there is a moment for questions. Yeah, we are very much open to hear your feedback and questions.
We are a bit over time, but it's just the whole day. Don't worry, not about you guys. But we have time for one, tops maximum 2 questions.
So do I understand correctly that if you're providing very frequent updates, for example, more frequent than the block time of Ethereum, which is 12 seconds, then the user of your Oracle actually gets to choose which of the time points they submit?
Yes, so it's up to a protocol to specify what's the allowed delay of a price feed. So even if you are on Ethereum, you can specify, for example, that you are going to accept only the price that is, like, say, like 5 seconds old. So it's been enforced and checked at the level of a smart contract, and then there is the validation of a timestamp. So it depends on the protocol. Usually, let's say the acceptance margin is larger, but if you are afraid of any kind of tricks done by user picking the most beneficial price, you can simply shorten the window, but as a trade-off, some of the transactions may not be mined if they are outside of that window.
Thank you very much for the presentation, very interesting. I'm wondering, are we introducing new centralized attack vectors here, like when the debt then talks to the resolver, then that's like a URL he needs to resolve to get the resolver that then access the data pool? And I mean, the verification on-chain, then it's clear there we can check the signature, but what are the central attack vectors between in the whole process?
I think, yes, that's an excellent question, because if we got this intermediary layer, like how can we trust into that, and what's the security guarantees of this intermediary layer? So therefore, we decided not to only build our own solution with something we call like a gateway or cache nodes that are used in the networks, and they're like a passive element. They just need to take a signed package and push it forward, so they cannot tamper with the content, but they may, let's say, stop working. And on that front, the code is open source. Anyone can spin up as many nodes as possible, but we also decided to work with an external solution provider, in that case, the Streamer network. I think they are even based in here. They are from Switzerland. And they got a very good and interesting and well-thought-through solution for the decentralized and accessible public subscribed network. And we utilize that also as an alternative to our own nodes, just to have a higher level of security, because we do not control the network. It's only a very passive mechanism when we push through the signed packages, and we benefit from, I think, around like 50,000 streamer nodes that are broadcasting the information.
Thank you.
If you have further questions, join our Discord and follow us on Twitter, redstone_DeFi.
Perfect, exactly. I was just going to say the same thing. Everybody put your hands together for Marcin Kazmierczak and Jacob Wojciechowski.